Today's notes are on topic 4, solving systems by elimination. So we've solved systems of equations by graphing, and that's where we graph and we find the intersections. We've solved by substitution. Graphing works well when we have access to graphing technology. We can also graph by hand, but sometimes that gets a little tedious. Substitution works well when we can easily solve one equation for one of the variables and not have too many fractions in the resulting expression. So for this, we're going to start by talking about why substitution is not a good option for solving the system of equations. So remember, your first step in substitution is to take one of the equations and either solve it for x or for y. So let's start by taking this first equation and trying to solve it for this x. Okay, so we would have 4x minus 3y equals 10. So let's add 3y to both sides. We get 4x equals 3y plus 10, or 10 plus 3y. The order there doesn't matter. And then we would divide everything by 4. We get y equals x equals 3/4 y plus, and then 10 over 4 would reduce to 5 over 2. Now, if we were using substitution, then we'd have to substitute that into the other equation where the x is, and this resulting expression has a lot of fractions, which makes substitution, it's going to just be more complicated. Now, let's try to solve this first equation for y and see what happens. So I'd have 4x minus 3y equals 10. So this time I'm going to subtract 4x from both sides. I get negative 3y equals negative 4x plus 10, or 10 minus 4x, the order doesn't matter. And then I would divide everything by negative 3. So I would get y equals, the negative divided by a negative would reduce to 4/3 x, become a positive. And then 10 divided by 3 doesn't reduce, so we would leave it at 10 divided by 3. Now again, we're stuck with those complicated fractions. So when we solved for x in the first equation, we got these complicated fractions. When we solved for y in the first equation, we got these complicated fractions. So maybe you're thinking, well, yeah, let's just use the second equation. So let's try that on the second equation. So 3x plus 5y equals negative 7. So let's try solving that for x. So I'm going to subtract 5y from both sides. I get 3x equals negative 5y minus 7. And then I would divide everything by 3. So then I get x equals negative 5 over 3y minus 7 over 3. So again, we got another equation that when we solved it for, in this case, x, we got these complicated fractions. And then one more. So we could take that last equation and try to solve it for y. So let's do 3x plus 5y equals negative 7. So this time we're going to solve for y. So we're going to subtract 3x from both sides. We get 5y equals negative 3x minus 7. Divide everything by 5. And I get y equals negative 3/5 x minus 7 over 5. So for even in this last time, when I took the second equation and solved everything for y, I got all these complicated fractions. And that's why substitution is not a good option, because we have too many fractions in this to be able to then substitute and have something easy to deal with. It's just going to be really complicated throughout to have to deal with all of those fractions. So this is what we use this other technique for. So in example 1, part 2, we have the same system we had here. So we've got the same set of equations, but we're going to use a process called elimination. And again, elimination is used when substitution is really just not a good option. And we're going to solve using algebraic method. Okay, in elimination, what we are trying to do is we are trying to add the two equations together to eliminate the x's and the y's. So for this particular question, let's say it's the y's that I want to eliminate. What I'm going to do is I'm going to take the first equation and I'm going to multiply it by 5. Now I'm going to distribute that 5 to everything. So that first equation becomes 20x minus 15y equals 50. Now, if you're wondering why I multiplied by 5, just give me a second and hopefully you'll be able to see why that's what I chose. I'm going to take the second equation and I'm going to multiply it by 3. So I'm going to distribute by 3 into all of those. That's going to give me 9x plus 15y equals negative 21. Now, with the elimination method, what we're going to do is we're going to add these two equations together. And what we want to happen is we want either the x's or y's to eliminate when we do that. So let's see what happens. 20x plus 9x is 29x. Negative 15y and positive 15y, those are the ones that are eliminated. So the reason I multiplied here by 5 and 3 was to be able to make this negative 15y and positive 15y, because I knew that then when I added those together, those would be eliminated. So those they cancel each other out. So then we get equals 50 minus 21 is 29. And so by adding the two equations together and eliminate those y's, I have an equation that's easy to solve for x. Now I would divide both sides by 29, and I get x equals 1. So if I graph these two equations, one of the parts of the ordered pair of where they intersect is 1. But I've got to go find the other part of where they intersect. And this does require that I do substitution. So I'm going to pick either one of these first two equations. It doesn't matter which one. So I'll just do the first one, 4x minus 3. And then I'm going to put, let me finish writing the equation. I'm going to put 1 in for the x. So it's going to be 4 times 1 minus 3 times y equals 10. So 4 minus 3y equals 10. Subtract 4 from both sides. Negative 3y equals 6. And then divide both sides by negative 3. So y equals negative 2. So elimination is used to find one of the variables. And then we do return to substitution to find that other one after we've found the first one. Okay, let's do a few more examples together so you get comfortable with this elimination method. So on this page, we are going to simplify all of these by elimination. We're not going to first see if substitution is going to work. We're just going to practice using this new method. So elimination is the technique we're going to practice on with all of these problems. Right, now in this first example, when I look at these two equations, I notice that I have a 4x and a negative 4x. So I know right off the bat, if I add these two equations right from the beginning, those are going to eliminate. So I don't need to multiply by anything first here. I get 8y plus 2y, which is 10y, equals 20 plus negative 30 is negative 10. Divide both sides by 10, and I get y equals negative 1. Now, once I have that solution, I pick one of the two equations. It does not matter which one. So I'm going to use the first one. And I substitute that negative 1 in for the y. So I get 4x minus 8 equals 20. Add 8 to both sides. I get 4x equals 28. Divide both sides by 4. And I get x equals 7. So if I would have graphed these two graphs and found where they intersect at the point 7, negative 1. All right, in the second equation, example 3, I've got 3x plus 4y equals 12, 15x plus 20y equals 60. I need to decide what it is that I want to eliminate, and it doesn't matter. So in this example 1 part 2, I chose to eliminate the y's. There are other things that I could have done. So let's just say I'm going to choose to eliminate the x's, okay? So what I have to think about is what would I need to multiply by to make those so that they would eliminate. In this case, I want to multiply the top equation by negative 5. So my top equation is going to become negative 15x minus 20y equals, so I'm distributing that negative 5, equals negative 5 times 12, which is negative 60. My bottom equation, I'm going to leave the way it is. 15x plus 20y equals 60. And now I can add those two equations together because that'll eliminate my x's. Negative 15x plus 15x is 0. But something strange happens in this question, that negative 20y plus 20y, that's also 0. So on this side of the equation, everything was eliminated, and I just have 0. On the right side of the equation, negative 60 plus 60, well, that's also 0. So that's a really weird kind of answer. But graphically, what it means is this is one of those ones where we have infinite solutions. We ended up with a true statement. 0 does equal 0. That is true. And when you have a true statement, that means that your two graphs were the same graph. So if I would graph these two things, I don't know exactly what they look like, but I think they're two lines that lay right on top of each other, right? And that means every point along that line is a solution to that system. So we write infinite or infinite number of solutions. So that one's a weird one. All right, example 4 and example 5. Now, although we could do these with substitution, I am going to do them with elimination today just so you can see how this technique would work on these kinds of problems. Not everybody likes to do them on these kinds of problems because substitution certainly would work, but we can. So what I'm going to think about in this question is I want to get my y's to eliminate. So what I'm going to do is I'm going to take the second equation and I'm going to multiply it by negative 1. Okay, so my first equation is going to stay y equals x squared plus 4x minus 1. My second equation is going to become negative y. I'm going to get a negative 3x, and I'm just going to put that underneath the 4x because those are the ones that are like terms. And I'm going to have a negative 1. And again, I'm going to line that up under the negative 1. Now I'm going to add those two equations together. Y and negative y drop out, so that makes a 0. X squared doesn't add to anything because it's the only one that has a squared on it. 4x minus 3x becomes just 1x or x, and negative 1 and negative 1 combine to give me negative 2. Now, this is an equation that I would solve by maybe completing the square, quadratic formula, factoring. I'm going to try to see if it factors first. Because if you have a quadratic, now remember a quadratic is where you have an exponent of 2. There's lots of methods you can use, but factoring is typically the fastest if we can factor it. So I need to think of numbers that are going to multiply to negative 2. That would also check to give me that positive 1 I need in the middle, and that looks like the right combination. So from there I can do x plus 2 equals 0 and x minus 1 equals 0. Subtract 2 from both sides, x equals negative 2. Add 1 on this one to both sides, so x equals 1. And then what I need to do in this question is for both of those, I need to substitute those back into an equation to find what the y is. For this question, it means that if I graph these, they would graph in two places. One place where the x-coordinate is negative 2, the other place where the x-coordinate is 1. So I'm going to take the bottom equation because it looks like a little bit easier. It doesn't have the exponent. And I'm going to put negative 2 in for the x. Right, so I'm always going to choose to try to pick what's easiest to substitute back into. So 3 times negative 2 is negative 6. Negative 6 plus 1 is negative 5. So that's my one solution, negative 2, negative 5. Then I'm going to do that again using the bottom equation. I'm going to substitute 1 in for the x there. So 3 times 1 is 3, and 3 plus 1 is 4. So when I put a 1 in, the 4 is what I got for the y. So that one has two solutions. All right, and I'm going to try that again here with example 5. So what I'm going to do is I'm going to try to eliminate the y's. To be able to do that, I'm going to take the top equation and I'm going to multiply it by negative 1. Now, it doesn't matter. On the other one, I use the bottom. But as long as one of these becomes a negative y and one of them is a positive y, they'll eliminate. So distribute that negative 1. I get negative y equals negative x squared negative 3x and positive 4. My second equation I'm going to leave the same. And I've done that so that when I add these two equations together, the negative y and the positive y drop out and become a 0. So I'm at 2x squared minus x squared, which is x squared. Negative 3x plus 5x is 2x. 4 minus 3 is 1. Now that's a quadratic because it's got an exponent of 2. So your methods here would be factoring, completing the square, quadratic formula, inverse operations. But I almost always try to factor. And let's see what I got for this one. Oh, I could do 1 and 1 because those are the numbers that would multiply to 1 that would make that 2x that I need in the middle. Now those are the same, so I don't have to do this twice because I'm going to get the same answer. X plus 1 equals 0 and x plus 1 equals 0 are going to be the same equation. So I get x equals negative 1. Then I'm going to take that and substitute that back into one of the original equations. To me, it looks like the top equation looks a little bit easier. So I'm going to put negative 1 in for those x's. So negative 1 squared plus 3 times negative 1 minus 4. So negative 1 squared is 1. 3 times negative 1 is negative 3 minus 4. So 1 minus 3 is negative 2 minus 4 is negative 6. So my solution on this one is negative 1 comma negative 6. All right, and that's the elimination method. It's a method that is a good method. Sometimes substitution is easier, but that's how the technique looks, and we'll keep practicing so you get better.